All right. Hello, everybody, and thank you for coming to OpenHour. This week, we're going to be talking a little bit about air quality and air pollutants and air monitoring tools, and we have a variety of interesting topics this evening under that people are interested in, including hydrogen sulfide sensing, silica, the Dustino project, among many other interesting topics. So if you're viewing this, you can actually join us on the call live on the OpenHour page by clicking that button there, which will direct you right into this call. If you'd rather just stay and watch, that's fine as well, and you can communicate into us through the chat room that's listed right below the page. So thank you, everybody, for coming, and really looking forward to it today. And just for the sake of annoyance, I'm probably going to repeat how people can join a couple times. So sorry in advance for a little bit of redundancy. All right, so the topic is air pollution and air pollution monitors. And Matthew, did you want to go ahead and start with a brief intro? Are you in a good place right now for that?
Sure. Yeah. If no one objects, I could go ahead and kind of kick off.
We should clarify we have two Matthews.
Oh, sorry. Yeah, I thought I was number 2 on there, so I was kind of confused. But yeah. Another Matthew can go. Yes, absolutely.
Yeah, sorry for the rapid change of venue. It just started raining. I thought it was going to be clear outside, so I rapidly went for some shade. Okay, so let me just screen share. So I'm going to talk about silica monitoring and our current project there. So the 11th Hour Foundation has funded public labs to do an exploratory project in assisting communities in Wisconsin in monitoring silica dust. And well, what is the problem? The problem is that construction and mining cause a significant amount of the dust in America. In fact, I'm dealing with an eye problem in my left eye right now, and had to rush going through this presentation because I couldn't use my computer over the weekend because a piece of dust got in my eye. And actually, a human being is probably responsible for that dust because at this point, anthropogenic dust is the largest source of dust in the world. And in Wisconsin, one of the sources of dust are giant holes in the ground, such as this. This is an image credit from Mikey O'Connor and the Sandrock Frisbee blog. And so if you notice, off to the left of the photo, there's a tiny little thing that is, in fact, a giant caterpillar steam shovel. So when we're looking at dust, what are the problems of dust? Well, the problems of dust are when it gets small enough, it can lodge itself in our respiratory system. So the yellow range here are particles that can get into your lungs from breathing through your mouth and deep into your lungs. And you'll notice that there's a peak at about 3 to 4 nanometers in diameter. And here is the type of dust that is released during mucking or dry drilling, so during typical mining operations. As you'll notice, it corresponds almost directly to the type of dust which is really bad for you that can get deep into your lungs. So this is John and Kristen Pierce's team out at UW Eau Claire deploying a whole series of different monitors. These are kind of the contemporary strategies for examining dust and silica dust. John is setting up a Dust Track 2, which is a small particulate monitor, and I'll talk about how those work in a second, a light-based one. Behind him are a series of EPA-certified filter tests that suck air through at a very steady rate and try to collect particles at filters that are specific to different particle sizes. So here's Kristen Pierce holding one of those filters. You can see that the dust has settled down onto those little spots through the filter. There's also, he's holding 2 vials in his hand on the left is unwashed sand, and on the right is washed sand. So the companies are mining, washing, and separating out different grades of sand. And by doing so, they are generating a lot of dust and sand that stays on site and can potentially blow around and cause some serious health problems, including complications with asthma, and silica dust can also be carcinogenic. So there are a couple of projects to monitor that are already ongoing. This is a Dylos monitor. It's a commercial air quality monitor that measures particulates. It costs about $200. Hank Boshian and the Chippewa Concerned Citizens are using these to do some citizen monitoring, and Jeff Falk has been doing an analysis of that data. You can see more about that on the public lab site. I posted a little bit on his analysis. And this is a Don Blair image. This is how that monitor works. It looks at a pulse of light, and the pulse gets interrupted by an air particle going through, and that particle, the interruption, corresponds to a specific particle size, roughly. There are some things that have to be checked there. This is Matt Scheuer. We're talking about this. Betty Scheuer. We'll talk about this later. This is the Dustuino. It uses the lower cost alternative to something like the Dylos monitor, and it also uses a small light-based sensor, like this one. So this is a Chenier sensor, and it uses a little focused LED photodiode, goes through, shines light through a lens, and this resistor is a heating element that causes a continuous flow of air through the device, and the diode, the photodiode detects interruptions in the light. So that's one way to look at dust. I'm getting really interested in another way to look at dust, which is this is a directional, what's called a sticky pad from Dust Scan. And these have only thus far been used for what's called nuisance dust, which is dust of a variety of different sizes, not necessarily small dust. But it's essentially a giant piece of tape that picks up dust. I was just talking to Thomas Peters at the University of Iowa, and his group actually has some dust accumulation rubrics that may be useful for this, that are based on collecting dust in little tiny, similarly cheap sensors. I'm also looking at ways to monitor that using light. So a traditional way to distinguish silica particles has been polarized light microscopy. So here's a really quick, large-scale polarized light microscopy. All the little glowing crystalline things are quartz sand crystals because polarized light causes them to glow in rainbow colors. So those are the ways that I've been looking at dust. We're also looking at supporting existing researchers, such as Tom Peters' team and Kristen Pierce's team in their current dust monitoring efforts, and also helping out citizen monitors such as Hank Boshian. So that's the state of our current dust monitoring, and perhaps I can turn it over to Matthew Scheuer. He can talk about developing a tool, which he's been working on, the Dustuino.
Cool. Awesome. That's that is excellent work, and thank you for presenting that, and also going into the Chenier, which is what is at the heart of this Dustuino, which I'll talk about in a little bit. But more than the technology, I think it'd be really neat to talk about kind of how this all came about. Because I have a background in a number of areas, and it's kind of like how Public Lab has people who participate also from a variety of fields, environmental scientists, and concerned citizens, and hackers, and stuff like that. Part of my background is journalism. I have a master's in journalism here from the University of Illinois, in kind of specializing in kind of data-centric journalism. And there's a trend now, thanks to kind of the lower cost sensors coming down the line, and kind of hacker technologies like 3D printing, and kind of open source electronics like the Arduino and Raspberry Pi and stuff like that, that journalists can now not only obtain data from, say, like the EPA, but rapidly approaching a point where we can collect our own reliable data, which is excellent when you see kind of the trend of EPA monitors being reduced kind of nationwide. I know that's the case in Illinois and in Michigan, and certainly with budget crunch issues. Quickly you can start to see how there's a lack of information even from governments. So, and oftentimes governments don't place their sensors in an ideal location. So it's all a great reason to start to look into how can we create this stuff. So I reached out to my network and for a number of things. One is the Fab Lab, and I'm going to try to pull up a photo of the Fab Lab, which is just really really instrumental in helping me create this, because the idea was that so I mean, this could be useful for a journalist to sense particulates in the air, but if we really want to do this on kind of a massive scale, without actually having to do kind of a full-scale production at a factory, what you need to do is harness the power of the hacker communities and places like Fab Labs and makerspaces, which is exactly what I tried to do in developing the Dustuino. So as in previous photos showed, kind of like the construction of the box, which is kind of important. So the idea here was to make something you could flat pack, almost like, you know, IKEA or something, but basically it's these quarter or eighth-inch thick acrylic plastic sheets that have this really fine teeth structure to them that just kind of snap into place to create a basically a box for your sensor. But of course, what goes inside the box? Initially, we started reading the Shinye dust sensor with an Arduino, and so that was always in prototype form. But we've been able to take the prototype Arduino, and since all of this is open source, it's very easy to go onto a program like EagleCAD, which is what I use, and to design just a custom circuit board. So this is about 2 inches by 2 inches. The idea was to keep the components down to a bare minimum. So you have the the microcontroller chip, which is a run-of-the-mill Atmega 328P, the same kind of chip you get in your Arduino Uno, a voltage regulator to help manage the voltage, a programming port so you can hook it up to the computer and reprogram if necessary. Ideally, you just program it once and then run it basically until it quits. A port to install the dust sensor, which is installed in this right now. This is actually the Shinye sensor itself. And probably one of the most important parts is a radio module, which is just very small. It's this size. This one actually connects to Wi-Fi. So with that, you can send your data off to Xively or ThinkSpeak, or the new SparkFun service. Or really, it's meant to be open, so you could even set up your own server at home. And so the idea was that everyone, could make these in their homes. What really kicked off this idea for me about doing this on a wide scale was back in 2012 when I'd already made a prototype of this stuff. I had a friend of mine who just got a new camera and was out taking photos one day, and not far from here, a town called Hoopeston, Illinois, there was a used tire depot that caught fire. So basically, 1 million tires went up in smoke, and you could see it from space. It was just such a massive tire fire, and I think I have a photo here I can share. It was just massive. I'll have to come back to that later. But the point is that so the people in this town, right, were concerned about the air pollution, because the EPA came in with their own monitors and said, well, this is not a healthy level of particulates. Everyone needs to evacuate from this town. And I later tried to dig out the numbers to see, well, what did they read? What was the readings that was making the EPA say that it was unsafe for people to live there? And so I filed FOIA requests. I did all kinds of I went down to the EPA office in Illinois or in Springfield, Illinois, and got their state EPA documents, and not one of them had any kind of quantifiable data on the airborne particulates. Just none. No information whatsoever, but it was a big decision because they evacuated this entire town. What I did find was a bunch of emails and letters from concerned citizens. There was one from the superintendent of the schools there, and warning the law. Our school starts up here shortly, and is this a health hazard for our students? This soot is collecting on our feet, and children are tracking it indoors. What's going on here? And even I, spending months on FOIA requests and following up with the state's attorney general to try to get the IEPA to respond to this, could not find the information. It was kind of an epiphany. Like, well, if the state's not going to collect this stuff and save it and give it out, then who is? That's a concern not just for journalists who are trying to do environmental reporting, but also people on the ground who want to collect this for themselves and make their own decisions. So that kind of led to a lot of this stuff as well. Also teamed up with some environmental journalists who wanted to know just about that. So I've been building some solar-powered dust sensors to go out to Mongolia, and they'll be there over the winter to measure the kind of pollutants that you get from burning wood, coal, organic and organic matter for heat. So that's kind of where the project is at this point. We open source all of the results online so that you can build one yourself. On Public Lab we published instructions on how to build one in prototype form, and we're going to follow that up with instructions on how to build solar type ones. But I'll be happy to answer any questions about that project and just, I guess, carry it off to the next person.
I was on mute, sorry, hazard. Great, thank you so much. Actually, we do have a question right now from somebody who's in the chat room, and we can do a few questions, and then we'll maybe move on to a couple others. But how do these low-cost sensors compare to the EPA sensors? And I guess that's a question for probably both Matthews.
Well, I could say really quickly, the way the EPA sensors, current EPA methods that are approved are all filter-based methods. So there are particulate measuring methods, such as these light-based sensors, but it all has to be correlated to a filter that collects the particulates, that's then run through either a mass spectrometer or X-ray spectrometry system in order to identify the particulates and identify the sizes of the particulates. So those are the current EPA accepted methods, and the EPA seems open right now to expanding the definition of what they're accepting, the type of data they're accepting. But that, as of right now, those are the current EPA accepted data. So any sensor, such as the Dustuino or something, to get the kind of officiated data, I would say, not high quality data, but officiated data, would have to be correlated with one of those EPA filters, probably within the geographic region it's operating.
Mm-hmm. Yeah, that's one of the biggest. Well, I'll add that the sensors are much better than what they used to be, especially for the price point. But there's also there's a number of hurdles, as Matt was referring to, because EPA collects things on those filters. They weigh them. You can find out what kind of dust, the composition of the chemicals that might be there. For instance, lead could be in that sample. The sensors that we work with, the low cost stuff that we're working with right now, as was shown in the image, is basically optical in nature. So instead of taking that sample of the dust that was collected on the filter paper, we're shining basically an infrared light inside of a tiny box and trying to measure how that dust reflects or changes the light inside that box. So these sensors claim from the factory that you can interpret a particle count from those from their methods. There's a number of issues with just measuring the particle count as opposed to measuring the actual dust in those other methods, because you don't know the composition of what's in there. So it could be something much more carcinogenic than you would know, because you wouldn't have the dust to actually study. But we try to get around that just a little bit. In our Dustuino code that we have for the Dustuinos that use the Chenier sensor, we've tried to look at a number of studies that that tell us kind of what you would expect a certain particle count to equal in kind of the EPA or EU standard, which is micrograms per cubic meter. So you're basically converting from a particle count to a mass concentration by assuming that the particles are of a mean size and that they're a mean density, and from that you can try to convert that. So there's error in each step of that way, from counting the particles to try to and estimating an average size and estimating an average density for those individual particles. But what we found in kind of laboratory testing with more expensive equipment, including Dylos and kind of the traditional filtering method, is that these sensors, while we don't know the composition, they track pretty well with what we see from more expensive units, especially if you monitor something over many hours, which is what the EPA does. It's generally a 24-hour standard, is what they look at. So if you're not looking at smaller time frames, then you tend to get better results from that average. So that's kind of the limitations that we're working with this right now, and the ways we're trying to work around it.
Great, thanks for the response to that question. And I see you've joined us now, David, but I was just going to read your comments, and you can correct me if I mispronounce it then. Just that the EPA has a federal equivalent method that works on detection principles other than gravimetric. But you can speak more to that now that you're, I think, on the call here live.
Yeah, sorry, I was having trouble getting on live.
That's fine.
Yeah, so I mean, the EPA does use methods other than gravimetric. In fact, a lot of the when you see the AQS Smart, the air quality online data, that's pretty much in real time. You're obviously not looking at the gravimetric monitors. They really use the gravimetric monitors for quality assurance, and when you have an area kind of on the cusp of attainment or non-attainment, those are always the final determination. But for the most part, a lot of the data you see online is real time. It'll be the TOM, the tapered element oscillation method, which is like a vibrating filter, and then the other method that's commonly used is beta attenuation. So it's like beta being a type of radiation going through a filter.
Great, thanks. So I'm going to check here. There's been a link to an example of community dust monitoring project that's posted on the chat page, and it's gcmonitor.org/coal-report C-word. And Scott, I think you posted that. If you want to go ahead and I don't know, do a research note on that so we can learn a little bit more about it, that would be great. And there's a new. Okay, Sarah, looks like you're on the chat here on the page. Great. All right, everybody's good. So we've covered a good bit about dust and a little bit about silica. And I know that we have some people here who are interested in hydrogen sulfide and hydrogen sulfide monitoring and sensing. So, Sophie, do you want to talk a little bit about the project you're doing? And that'll leave us some time. I think there's another one after you, and then we can have another discussion.
Yeah, sure.
Thanks.
Okay. Hi, I'm Sophie. I'm a student at Grinnell College in Grinnell, Iowa, and I'm actually doing this as part of the summer research project on CAFOs, or confined animal feeding operations, so basically factory farms. And we're working with a group at the University of Iowa with Peter Thorne, and we're going to study how CAFO emissions affect people in nearby communities, so within about 1 mile of a CAFO. So initially, what I was doing with my project was looking at how it affects people's moods and quality of life. And so the IRB was taking forever to approve the project. And in the meantime, I was looking on Public Lab, and I found this method of hydrogen sulfide sensing that was originally developed by Claire Horwell, and it was used on volcanoes in New Zealand. And I thought, well, CAFOs give off a lot of hydrogen sulfide, so maybe I can apply it to this, to CAFOs. And so I did a sample run. I made a couple batches in the lab here at school. I also developed a box. I made a research note on these. These are light-proof boxes because it uses photographic paper, and the paper reacts with the hydrogen sulfide and darkens. And so I made these boxes that are light-proof, but they allow air in. You put the film canister with a sensor inside, and I tried putting these in a small hog farm, well, relatively small. It's got 1,200 hogs in it, so that's considered to be a relatively low nuisance compared to the other ones. But last week we went back and got papers back, and I found that it does indeed work, which has been confirmed already. But what's exciting about this is that it works for CAFOs, so we can use this.
Higher.
So this is the one that was outside of my house, and these two were in the barn. And so now the next step is figuring out if we can get it to, if it detects hydrogen sulfide levels at or below 30 parts per billion, because 30 parts per billion is the legal limit in Iowa. And so we tried this method where we use emergency water storage bags and put the strips in there and use syringes to get hydrogen sulfide into the bags. And I posted this on the research note as well, but it was very inconclusive. I think it might have been because sorry, that wasn't fast enough. The strips were kind of jostling around inside of the bags, so the coating that is required to activate them may have worn off, and also our methods for syringing hydrogen sulfide into the bags were kind of sketchy. So now we're kind of just waiting for the University of Iowa team, and we're going to deploy the homemade sensors side by side with their sensors, which are radiello, which uses methylene blue, and that will be hopefully a way we can try and quantify it, because that's the criticism we've gotten the most. That's not quantifiable. Although I do like, I think, yeah, someone's also pointed out that just the dark discoloration is very powerful on its own. So we're going to, it's going to be a couple of weeks now. My housing permit is running out, so I'll be home. But I'll be back in the fall working on it still, and looking forward to it.
Cool. Thanks a lot, Sophie. That's really awesome. I love the box. Can you show it again? Can you show the inside higher?
Yeah.
Very cool. Very cool.
Thank you. There's 40 of these behind me. Just waiting, gathering dust.
Oh, good. You're in the right room then.
Hold it up one more time. Sorry, I couldn't see it.
Yeah, no problem. I can link you to my research note as well if you'd like.
Cool. Thanks.
Yeah.
And then is Liz, is Leaf around?
Yes. Yes. Let's get the video on. Can you see him?
With our video turned back on here. Hang on, just a second. Anyway, so looks like the video is having trouble coming back up, but can you guys hear me?
Yeah.
All right, so my name is Leaf Persfield. I've been a contributor to Public Lab for a little while now, and I work on all sorts of other different stuff. And I wish I had the video to show you, because I have some stuff here. So maybe I'll play with this for one more second before I dive in there. Hang on just a second.
Even says it's broadcasting.
Oh, okay. Looks like the video. Somebody says the video is fine.
I think the video is fixed on the page. Do you have a picture you were going to screen share, or what were you?
I just have some stuff here to show you, but anyway, it's not that big of a deal. So I was asked to talk a little bit about the air quality egg project, which is now a couple-year-old project around, very much the same topic, distributed air quality monitoring, and came about as a kind of a meetup group actually here in New York, and then spread to a bunch of different places in kind of all over the world, really. And there was a bunch of workshops in Amsterdam. We did workshops in London, and it's tracked actually very well with some of the work that Public Lab has done. And there's a research note from a derivative of the air quality egg as a tool, maybe. I don't even know where it is on the Public Lab site, but it's the balloon-based air column monitoring sensor, or some ridiculously awesome name. And the idea behind the air quality egg was to capture basic air quality parameters that you can get with low-cost sensors. We have sensors on here for volatile organic compounds, nitrogen dioxide, carbon monoxide, and ozone. And then as well as temperature and humidity, we use a simple optical dust sensor in the form of either a Sharp or one of the Genie sensors that's been discussed before. But what the real approach to this project, and the kind of the striking success and catastrophic failure, maybe I should say, or I don't know if I'll go that far, but was a successful Kickstarter where 1,000 of these devices were sold and distributed to people throughout the world, and had then the information get posted online in real time. And the real idea behind this was not to create an EPA level monitoring system where we could accurately say we had a parts per million or parts per billion accurate sensor to say, oh, the NO2 is too high and we're issuing an air quality alert. But the big picture idea was to have comparative data, to say based on 2 sets of data, you could say what sensor was high or low, and what was reading high or low, what the trends were reading high or low. With 1,000 of these deployed throughout the world, you could get a really good picture of what was happening. And so in some way, I think that that's still the biggest success of this project, even though a lot has been kind of bogged down in terms of getting measurable, quantifiable data that can be compared to other different types of air quality resources out there. And Liz just pulled up. We went through, so speaking of the EPA testing, we actually had the air quality egg shipped off to North Carolina, or maybe it was flat here in New Jersey.
No, it's RTP.
Yeah, so Research Triangle Park in North Carolina, they ran the full suite of tests against their, who knows how many hundreds of thousands of dollars of equipment, laboratory quality equipment, and got the results back. And let's see, let me see if I can switch to screen share here, just so you guys can get the full effect of.
That's Stevie, she'll tell you.
Yeah, if you run your mouse over the top, it's the green arrow, or the green box with the white arrow on the left-hand column is the screen share. And then if you pick the one in the top left-hand corner, that'll show your desktop, and you can minimize the Hangout and show whatever you want to show.
I don't know. I'm on Liz's computer. I don't see it, but anyway. The long story, the short story of a long story, or the short answer to a long story, is we got our information back, and our NO2 concentration accuracy, the test was the most successful because the test was 90% complete, and our accuracy is 10% and our precision is 5%. So we are plus or minus 5% over 10%, which is not so good. The things that we were sort of good at were the O3, using our chemical sensor, we were 25% accuracy, but with a 25% precision, meaning that we were accurate within plus or minus our accuracy. So there's some big gaps in exactly what we can provide in terms of data that is quantifiable in terms of, like I said, this EPA level saying parts per million or parts per billion in this sense. But the sensors themselves are manufactured to a specific tolerance, and then the components are put together in the same manner so that we can basically guarantee that within the accuracy of the manufacturer's specifications, our sensors would function about that well. And then compare that to another set of the sensors. You can say, well, within any number of these air quality egg devices that are out there, they are accurate to each other. And that was really the big success and the big push behind this project, getting that out. And so, airqualityegg.org, the site, you can see all the eggs that are online. You can check them out. Hopefully, they're still online. I haven't looked in a little while, but yeah, I'm happy to answer any questions.
Great, thank you. I think that there are a number of questions that have been posted on the chat page here and on the chat page on Public Lab, and some of you I think are on here, and we'll just go ahead and start addressing some of these questions. And Scott, I see your question up here first. Oh, never mind. That was a statement about your post. Right. Okay. Crispin Pierce, Professor Pierce, hello. How are you? I see you have a number of questions here. Is your audio on, or would you like me to read them? Yeah, we can't hear you. I think your audio is not coming through. I'm going to go ahead and read your questions. Okay, great. So Professor Pierce asked, for the hydrogen sulfide monitor, Sophie, has ammonia, which is also emitted from the CAFOs, been considered for monitoring? Test strips available? Test strips, they are available, yeah.
Okay, yeah, that's not something that we've looked into yet, partially because that's not something that has an established legal level, so it wouldn't really provide much power to locals, and that's what we're starting with right now. But that would definitely be a good next step, or a good place to go after this.
Professor Pierce, I would love to see your post for the or information about the test strips that are available.
Yeah, I'd like to look at that too.
I'm not sure if you're on the Public Lab webpage, but if you could post that or send me an email, I can get it up there because it would be really valuable information. We're dealing with a number of places. And also, just to note here that if anybody who's watching, I know there's a number of people who are just watching, you can post questions on the Google Hangout page if you're there, on the Public Lab chat page if you're there, and we'll get them. So some of the other questions here are for Professor Pierce also asked, using IPD for organic vapors. Was that for the egg, Professor Pierce? Not for yes? Yes. Leif, can you answer that? Was it using IPDs for the organic vapors? PID, sorry, dyslexia is kicking in.
PIDs. The organic vapors are basically just a get the book. So all of the sensors are metal oxide sensors, and so it's basically just a little piece of reactive silicone that gets heated up, a little piece of metal that reacts when it's heated up, and in the presence of that chemical changes resistance. And so they're pretty simple and they're pretty cheap, but they do have kind of wild swings. And certain metal oxide sensors are actually sometimes more susceptible to other compounds in a similar nature to the compound that you're actually trying to measure. And so occasionally you can get noise based on input from a different compound that you're actually not trying to measure. So those are sort of the pluses and minuses. They're also really cheap compared. I mean, the whole air quality egg, I think, the Kickstarter was for $125 or $150 or something like that, including an Ethernet port and wireless communication and all that stuff. So it was amazingly cheap and was about as good as it ever was. So.
Great, thanks. And there was a question here, I believe, for you, Matthew S. as well, about the dust we know. Is it affected by humidity?
Yeah, the truth is we don't know because we haven't tested it for in a laboratory environment, controlling for humidity and looking how that changes over time. But we do have we have tested it in compared to some other more expensive units. Let me see if I can screen share to show you because it was kind of a really neat collaboration this process because I ran into some people at a one of these maker fairs where I was presenting, and it was let's see if I can't. There it is. I'm going to share this. So let's go into presentation mode. So ran into some students who were trying to solve a problem for I believe they were first-year graduate students trying to find out or do a study on kitty litter. So here we are in a lab with a climate. Over here on the right is the climate. It's a much more accurate unit, and we have 1, 2, 3, 4. We had 5 of these Shinye sensors lined up at the same time, collecting data, all on a laptop. And we had someone who disrupted the kitty litter. We were testing basically what's kind of what's best in terms of dust mitigation, because there's a variety of kitty litters that claim low dust and all this stuff, and here's a closer shot of all the Shinye sensors, and this is the result here. The paper that the students wrote showed that there was some decent agreement. So this blue line here represents dust we know. I'm pretty sure this is PM 10. The units are micrograms per cubic meter. The red dotted line is from the climate, and that is a bin containing just PM10 alone. And you can also see there's a yellow dotted line here, which is the climate's TSP, which I believe that's the total measured from I think 0.1 micrometers or 0.1 up to PM10. I'm not so sure about that, but that kind of shows all of the particles, not just the PM10. And you can see where the Dustuino had a large spike, and the climate kind of trailed after that. So there was some decent agreement. We also went out in the field, and so to speak, and measured actual litter boxes in the real environments, and we saw
Matthew, sorry to interrupt. Are you showing a graph right now? We weren't seeing it.
Oh, it wasn't coming up?
No.
Oops. Well, I'm gonna not screen share then, because I don't think that's working.
I think we're seeing what you're seeing. Just click on the one that is the graph. Yeah.
This one?
Yep.
Yeah.
There we go. Thank you.
Is it up now?
Yes.
Yeah? Okay. Yeah, this is the graph. So this is laboratory. This is not field. This is in our in the College of ACES, Agricultural Sciences. So I mean, it has spikes on the short term, but over the entire period, it tracked fairly well. So we were happy with those results, but we don't know what the humidity is, and so that's one of the limitations there.
If I could jump in there, there is an article, I'm going to post it into the chat room in a second, that Willie Schubert actually posted on the Shinye sensor. It's a pre-release study from Berkeley called on the Shinye sensor, and they reported that there is a negligible linear correlation between humidity and that optical sensor.
Oh, okay.
So
That's cool.
Correlating for humidity data was important, but fairly simple with the sensor.
Cool.
And I'm not sure if that is similar to Crispin's experience with the dust track or other optical sensors, but it sounds like it. You said earlier that you had calibration. You had some calibration information on the dust track, so perhaps it's Here, let me put that in this drop too.
Sure. I think the study was done, or one of the authors is Edmund Sato at UC Berkeley, and he's been really helpful. Willie Sherbert is from the Internews organization, Environmental Journalist Network (EJN), and that organization has helped fund some training exercises with the Dustuino. Made 10 of these and taught journalists how to make them up there. And Edmund Sato was also working on noise detection equipment, so basically low-cost decibel logging meters. And so that you can imagine a scenario where you have both dust and noise, and those are two big issues in an urban environment that can harm your quality of life, that you could work together on.
Great. There's a couple questions here for Sophie that I've been seeing. One from Sarah. Do you want to speak to your question?
Sure. Hi, Sophie. Great to see you.
Hi.
I was just wondering about two things. What levels of H2S did you use in that calibration test? And I was interested in that gradient on the test strips. I've never seen that before, and I wonder if it's a side effect of the baffles.
Yeah, that was, we found that very interesting as well. So the calibration test, we were at 0, 5, 10, 20, 30, and 50 parts per billion. But
So
this was...
50 was your highest. Did you see
50 was
anything?
our highest. But again, there's probably something wrong with the method. It was a very experimental method. And we don't know what the levels were in the barn where we actually got the results.
Mm-hmm.
The gradient, I think, was because I've got a film canister to show you. We put the test strips in, like, oriented like this. And then later, talking to Elizabeth Wilder, we found out that they go in like this. So that's how we'll be doing it from now on. So yeah, we just think that the darker edge is probably, it was the edge on top, so it got more exposure. So that's a quick fix, hopefully.
And there was another question online on the chat page from Scott that says, could the film strip method be quantified in Photoshop with a histogram?
If that's similar to, we're trying something with ImageJ, which is like kind of free Photoshop, and using integrated density, or is it integral density? Let me check on that. But it has to do with grayscale and how dark the scanned image is, and with the gradient, it was kind of hard to determine what exactly we were looking at. So I'm gonna.
I was just gonna say, Sophie. Yeah, the histogram gives you an integral of the volume of the area underneath the graph of of color intensity. So it's probably similar to what you're doing.
Okay, that makes sense then. Yeah. So I've tried that. Actually, I do have a small graph of that. I can try and pull that up and screen share. Basically what it showed was that it was 0 on the white one and very high on the dark ones. But I don't know how sensitive it is yet. We'll need more data. But that's showing some promise, I guess.
Great. Did other people have comments, questions, or thoughts on any of these topics? I'm realizing the air quality one was a really big one. There was a lot of different topics. I see there's a number of links that have been posted on the group chat page. If people are interested in following up on those on research notes or even just on the public lab chat so that everybody can see them, then we can share out some of this information that we've developed here. So, Crispin Pierce is saying, I think we all need atmosphere generators. $10,000.
Let's start a Kickstarter.
Yeah, that'd be a good Kickstarter.
Yeah.
Well, I wanted to mention that here in New York, Jeremy Barron also just came in. He's an awesome. Yeah, our video is like messed up right now, but Public Lab NYC member and dedicated Wikipedian as well. So yay, allied open source community. I guess, does everyone know how to stay connected with the air quality discussions on our listservs and on our website?
Great point, Liz.
I don't know, Stevie, maybe you want to go over like how
Sure.
to subscribe to that stuff?
Yeah, so if you go to publiclab.org, on the top center, there's participate. I believe that's what the tab is. Correct me, Liz. And then the third one down is join discussion list. And on the top is just a general public lab. It's published every week. We do updates. But for specific topics, on the left-hand column, there is one dedicated specifically to air quality. And that's where a lot of these great topics and questions pop up with Public Lab, and when we're incubating research notes and things like that. It's a really good group of people to bounce ideas and thoughts off of. So if you're not on that, I highly recommend joining. So a really good group of people with really great ideas. So, all right. And I have a note here from Professor Pierce that says, I wanted to extend an invitation to all who might want to test particulate monitors. We are using EPA FRM monitors for the lab and in the field, and can co-locate the monitors for testing. Excellent.
I might send a couple of these your way then, if you don't mind, Crispin.
Crispin Pierce, you're interested in the Dustuino? Yes, appreciate that.
Cool. I will get in touch.
Great, and I can connect the two of you.
Thank you.
All right. Any other thoughts before we wrap up here?
I was going to add one more thing about how to follow this topic very closely on our website. If you'd like to know when anyone posts a research note on air quality, you can just follow the link I put in the chat room, publiclab.org/tag/air-quality. And when you're logged in, you can see that you have the option to follow air quality as an RSS feed, so you'll get emailed if anything gets posted regarding air quality. And there's many people that cruise the site and make sure that things get tagged properly. You can also, we now are actually overlaying a question and answer format on top of our wiki to have a bit of a Stack Overflow feeling. So you can also ask a question about air quality or sign up to answer questions about air quality by following the same link. Thanks.
Cool. Thanks, Liz. And before we lose anyone here, just going to throw out that next week we are actually we're doing an open hour again on tools. It's been a really successful series, and we're really excited to announce that next week we're going to talk about thermal imaging and the fishing bob, and hopefully we'll have, I know we'll have some good presenters on that tool on the bob. That's detecting temperature in water, and I've seen one of them created and used, and they're excellent tools. So we're really excited about that next week. So I'll leave open for just another minute if anybody has any other questions. But other than that, thank you so much for joining this evening. It's been a really great discussion, and these are really fabulous tools, and I really appreciate everybody's time and dedication in joining, and look forward to hearing more about them on Public Lab. And thank you all very much. Thanks. All right. Well, I think that's it. Thank you so much.
Bye.
Bye.